Hi guys, so today we're going to go over what a reference angle is. Definition-wise, a reference angle is an acute angle, and keep in mind that acute angles are less than 90 degrees. The reference angle is also notated with this symbol, theta, and a little slash next to it. And it's formed by the terminal side of theta and the horizontal axis. So what does that actually mean? So I kind of put a little diagram here for you, but in the end, you're really not going to need it after I explain it to you, I think. So I've already started off, let's say your angle is in quadrant 2. And I just made up 120 degrees, by the way. I just made up an angle in quadrant 2, which is 120 degrees. So let's say your angle is 120, which is right here. Well, not really, but close enough. Um, so the initial side is always at 0, because that's where the angle starts. And from here to here would be about 120 degrees. So that would be theta. So to find the reference angle, I'm taking the terminal side of theta, which is right here. This is the terminal side where it ends, and its closest horizontal axis. Well, the closest horizontal axis to it is right here. And as we know from our unit circle, that angle is going to be 180 degrees, or pi, depending on if you're working with degrees or radians. So that means the reference angle is just the difference between 180 and 120. So the reference angle is 180 degrees minus 120 degrees, which is 60 degrees in this case. But formula-wise, if you have an angle in quadrant 2, you would just take 180 minus that angle, or pi minus that angle if it's given in radians. Why? Because the closest horizontal axis to it is 180 or pi. If your angle is in quadrant 3, so let's just say that the angle happened to be 225 degrees, which is about here. Initial side always starts at 0, so from here to here, the angle is 225 degrees. Again, this is the terminal side of the angle, which we have, and now the closest horizontal axis would still be right here. The closest horizontal axis is still going to be 180 degrees or pi. But the only difference is in quadrant 3, any angle in quadrant 3 is going to be larger than 180 degrees. So to find the reference angle, I would take the angle minus 180 degrees. So if you note down here, anytime your angle is in quadrant 3, you would take the given angle and subtract it from 180 degrees. And again, if it's in radians, you would take the angle and subtract it from pi. So this would be your reference angle, which would be 45 degrees. And let's say your angle now is in quadrant 4. So we'll go with quadrant 4 about 300 degrees. Let's say quadrant 4, your angle is 300 degrees. So here's your terminal side. This is where it ends. Remember, your initial side is always where it begins, so 0. So this is your terminal side. This time the closest horizontal axis to it is right here, which when you come around to quadrant 4, that closest horizontal axis is at 360 degrees. So the reference angle is between here and here, which would be 360 degrees minus 300. So if I take 360 minus 300, I would get a reference angle of 60 degrees. So anytime your angle is in quadrant 4, that's how you would solve for the reference angle. Why don't I really have anything for quadrant 1 though? So here's the thing. If your angle is in quadrant 1, and I kind of made a brief diagram up here, the closest horizontal axis to it is 0. 0 degrees, 0 radians, whatever they give that to you in. And if you subtract anything minus 0, you're still going to get that same value. So if they ever give you an angle in quadrant 1 and they ask for the reference angle, those are the same exact values. The reference angle and the actual angle given, they're the same thing because you're subtracting 0 and that doesn't change anything. So let's try a couple of examples. Well, I actually did 300 degrees here. So Number one, considered a freebie. Um, so the reference angle would be 60 degrees since we already did that one, but the reason why is because it is in quadrant 4, and the closest horizontal axis to that angle would be at 360 degrees. So the difference between 360 and 300 would be 60 degrees, which is my reference angle. All right, moving on. Notice there's no degree symbol for 2.3. That means if there's no degree symbol, it's in radians. It doesn't always have to match a radian value from your unit circle to be in radians. Angles are written as degrees or radians. You'll know it's degrees because it has a degree symbol. Otherwise, it's in radians. We will keep calculating it in radians, but just to kind of see which quadrant I'm in and to throw a little unit circle knowledge your way, to convert radians to degrees, I would multiply it by 180 over pi. That's how you convert radians into degrees. So 2.3 times 180 degrees equals 414, and if I divide that by pi, I'll get 131 degrees. So why am I actually converting it to degrees if I'm going to calculate in radians? Well, I want to know what quadrant it's in, so that would be an easy way for me to know. So I know that 131 degrees is between 90 and 180, so I know I'm in quadrant 2. So at 131 degrees, I would be about right here. Initial side is always 0. So this is the angle 2.3. The closest horizontal axis to it is here, which is pi. And again, you don't have to keep doing the formula. You know if it's in quadrant 2, you would just take pi minus the angle. But I'm walking you through every single problem, I guess. All right, so here's the closest horizontal axis, which is pi. So the reference angle, which is between here and here, would be pi minus 2.3. So you're going to take pi minus 2.3, and you'll get 0.84 radians. So if the question is in radians, you'll answer in radians, unless otherwise specified. And then moving on from here, we have another value in radians, except we know where this one is. Theta equals 3 pi over 4. So in my unit circle, 3 pi over 4 is in quadrant 2 again. And we already know in quadrant 2, the closest horizontal axis is going to be right here, known as pi. So the reference angle would be, let me change the color. The reference angle would be that difference. So the reference angle is going to be pi minus 3 pi over 4. Now, just in case you wanted to use your calculator again, quick tutorial. Remember, in front of pi is just a 1. You can change it to common denominators to make it easier for yourself. So you could write this as 4 over 4, which is still 1. And then from here, we can subtract, since they have common denominators, by keeping the denominator and doing whatever the numerator says, which is 4 pi minus 3 pi, and that gives you 1 pi. All right, last one is negative 135 degrees. Now, I get it, it's negative. However, you've also learned about coterminal angles. You don't want to deal with the negative angles, that's fine. So find the coterminal angle, which means add a full circle to it. So theta equals negative 135 degrees. To find out where that actually is, find its coterminal angle, meaning add 360 to it. If I take negative 135 degrees and I add it to 360, I will get the angle 225 degrees. So me saying negative 135 degrees is at the same initial and terminal place as me saying 225 degrees. So technically 225 degrees I've already done. I didn't plan that, by the way. It just happened. So I already know 225 degrees is in quadrant 3. The closest horizontal axis to it would be pi, but anything in quadrant 3 is going to be bigger than pi or 180. So we take the angle minus pi or 180, depending on if we're dealing with radians or degrees. So to find that reference angle, we're just going to take 225 minus 180, and that'll give me 45 degrees. So notice that every single one of these angles, these reference angles that are my answer, they're less than 90 degrees, or less than pi over 2 if you're in radians, but they're all acute. So that's a kind of a good way to check your answer as well. Your reference angle should always be less than 90 degrees or acute. And that's pretty much it. I hope this helps.